We have a next speaker with us, Dr. Mohammad Farooq Hasmi. So, Dr. Mohammad Farooq Hasmi, senior member IEEE, received the BE degree in Electronics and Communication Engineering from MIT Mandusar, that is RGPV, Bhopal University in 2007. The ME degree in Digital Techniques and Instrumentation from SJSITS, that is the Indore, in 2010. Dr. Hasmi received PhD degree from VNIT Nagpur in 2015 under the supervision of Dr. Avinash J. Keskar. He is currently working as an assistant professor with the Department of Electronics and Communication Engineering, NIT Warangal. He has published up to 75 articles, including 25 essay index paper in international and national journal conference of publisher like IEEE, Elsevier, and Springer. He has published one patent to his credit. He was principal investigator of one research project of the worth 5 lakh funded by Institute Seed Grant through TCUB3. He has teaching and research experience of 30 years. He is also serving as an active and potential technical reviewer of IEEE Axis, IET Image Processing, IET Computer Vision, Wireless Personal Communication, IEEE System Journal, Sensors, Electronics, Diagnostic, MDPI, the Visual Computer, Applied Soft Computing, Elsevier, Color Research, the Journal of Supercomputing, and the various other journals like Elsevier, Springer, IEEE Transaction Publisher of the repute. He has supervised 2 PhD scholars. He is currently guiding 4 PhD scholars. His current research interests include computer vision, machine learning, deep learning, embedded system, IoT, DSP, image processing, and digital IC design. He is a senior member of IEEE, life member of IET, life member of IST, and life member of IAENG Society. So we welcome Hasmi sir. Now it is over to you. Thank you, sir.
Thank you, sir. Thank you very much. Thank you for coordinator for inviting me for this talk. So, dear participants, I would like to discuss today the topic of my talk as surface EMG based activity recognition and knee abnormality analysis using various machine learning and advanced deep learning based algorithms. So, related to this talk, first we'll discuss about how we are going to utilize specific for this lower limb, that lower limb analysis in healthcare with respect to surface electromyography, SEMG. So we know that today's in the trend of artificial intelligence. So I hope you have covered related to how AI will be utilized specific for healthcare applications and related to now we are talking about smart healthcare. There are many sensors which are nowadays became smart related to with this because of miniaturization technologies. We have seen that various sensors, various bands are coming specific for its lower limb detection. That means this is the applications area where we are talking about activity of the human, or as well as we need to know that how elderly patients or elderly people's who are suffering from various knee abnormality, if that is the aging factor, and how we can analyze specific for link particularly mobility assessment, rehabilitations, and assistive technology. So we can provide various assistive technology like smart prosthetics and exoskeletons, or basically when we are talking about various injuries, that means in injury point of view the predictive analytics will be implemented for prevent the falls and injuries, and we can see that early detections of the actions whatever the gait abnormalities are there. That means in terms of application point of view we have to detect the various disease under the lower limb. That means the how the particularly the knee analysis would be there, and also various injury or surgery after that what are the rehabilitation process are needed, that also would be helpful, and we can control the various assistive AI. So related to that, in today's trends, machine learning and deep learning is specific with connected to advanced signal processing. Basically, the signal processing where we can get the data from various sensors in terms of signals, one-dimensional signals related to ECG, EG, and also the same domain EMG also would be there. So by that way, we are making this signal analysis after the denoising or noise removal or filtering. By that way, we are able to utilize various advanced signal processing, and that would be helpful into the healthcare application. So according to the related to the signal analysis, we have the various kind of signal, that means physiological signals. So particularly, what are the physiological signals which are available, how we can deal with that signal. So particularly the physiological part, which will be very important in today's trend, because we are talking about the smart technologies which has been implemented to particularly to just specific for healthcare analysis. So healthcare monitoring system which equipped with various wearable sensors, wearable devices, and which is connected to various Internet of Things devices, and then we are going to deploy the various edge computing or cloud computing analysis, and it will be deal with the various telemedicine process. So physiological part, which is covered by various biological measurement. Basically, this reflect the what are the states of physiological process would be there in our body, and it is very crucial, especially for diagnosis point of view and monitoring of health condition. So when we want to know that what are the health situations of the elderly patients would be there, and how we can monitor them, because the particularly when the aging part will be there, so we don't know what are the conditions will deteriorate the particular patient's situation. So we have to monitor regularly by using of wearable devices. So this signal would be collected through wearable sensors, and signals are very important and it play very vital role in medical diagnosis. So when we are going to diagnose the patient, as well as we want to monitor the patients with respect to certain health condition, and we need to provide the therapeutic intervention. So various therapy will be given and how intervention will take place, and we how to enable the various advanced technology specific for personalized healthcare as well as treatment strategies. So we are going to provide the treatment and how the particular stages the treatment would be given. So it is very relevant in the medical as well as healthcare technology field. So that is the importance of the physiological signal part. So we can see various type of physiological signal that would be available, specific for electrical signal, which will be collected from various variable sensors in terms of electrocardiogram, in terms of electroencephalogram, or in terms of electromyogram. So these are the signals which is available, and these signals are generally the electrical activity of heart, electrical activity of the brain and muscles. Respectively, it will provide the particular insights into their functional health. What is the particular health condition would be there, that will be collected from electrical signal. So that is the sensing phenomena we can observe, that once we have observed the physical data which is collected from sensor converted electrical signals, so electrical activity of the brain, of the heart and of the muscles will be analyzed, and then we can see certain different other activity like without electrical part. That means it would be the non electrical signal. Sometimes we can measure the blood pressure, we can measure the temperature. So these are comes under the non electrical signal, which is very vital parameter, because under that pressure of the blood, in terms of blood pressure, temperature of the body can be measured, and by that way we can assess the and monitor the general health of the patient, as well as we can detect the what are the underlying medical issues are there. That means we can say some more parameter will come later like SpO2 or some other. All these are the part of sensors analysis. So we can understand first what are the signals. So our concern is, our region of interest would be EMG, surface EMG, because we are not going to insert the sensor inside the our body. We are just going to put the surface, so that would be surface signal analysis. So that is very important to understand, because when we are talking about electromyography, that is the diagnostic procedure, and we are going to assess the health of the muscles. That means what is the condition of muscle will be there, and we need to know the motor neurons. That is very important, but because the whatever the cognitive ability of the human brain would be there, how we can control them. So related to that, we can measure electrical activity which is generated by muscles contractions. That means once a person will walk, so what are the his walk will change, but if he's having certain issues under the limb or under the lower limb or under the knee, so his action will deviate. So we have to understand under the gait analysis. That means we have to measure the electrical activity as well as what are the activity, human activity will be there. So this activity will deviate, that will be measured by the muscle contraction. So there are various historical background would be there, how we have analyzed. So the development of EMG sensors, that back if we go to the 19th century, related to significant advancement happened from the past 25 to 30 years, like from starting from 20th century, that established a critical tool. That means that tool will be helpful, and it has analyzed by the various neuromuscular diagnostic and various research carried out at that domain. So there is a various history part would be there. So once we'll see the types of EMG, that means when we'll talk about various types of EMG analysis we can do. Particularly, surface EMG is very popular because it involves the placing the electrodes. So when we are getting the ECG analysis, we'll see the various electrodes can be placed on the nearby heart's area, and then we are going to measure on the particular CRO or what are the screen would be available. Based on that, we can analyze the certain QPRS complex analysis part would be there. That is the general analysis as we are talking about ECG analysis. But here in terms of surface EMG, that involves the placing electrodes. Various electrodes are coming which can be placed, or various bands are coming which can be placed on the skin, and that skin is connected or overlaying with the muscles. By that way we can measure the electrical activity of the muscles. Commonly this will be utilized for rehabilitations, and what are the ergonomics part would be there. That means under that condition it will consider as a non-invasive nature. That means there is a procedure where we can either insert the sensors or electrodes to the body, that is invasive to non-invasive condition. All way we are going to collect the data and we can monitor the data. So other type of EMG analysis, intramuscular EMG, it is insert a needle. That is the one kind of electrodes which can directly insert into the muscle tissue, and we can provide the precise electrical readings or electrical activity which can be utilized if you are looking for detailed diagnosis with limited kind of like noise part would be there. So that means detailed diagnostic is specifically for clinical analysis. So for clinical decision making point of view, we are going towards the non-invasive to invasive part. And we'll compare with ACMG to intramuscular EMG. That means completely it's a different, because ACMG is a user friendly, can be easily we can manage. As a researcher who are doing research in this domain, specifically they are able to utilize for at the surface level only. So surface analysis, muscle analysis, but the data which will be collected from the SEMG completely very noisy. We are going to deploy various signal processing or denoising algorithms are very important. So while intramuscular part we are going to offer, it will be very highly direct muscle activity, and the resolutions of that activity would be more precise as compared to SEM, but it is more invasive. Whatever the invasiveness and non-invasiveness part will be there, so it is going to be invasive. So invasiveness if it increase, definitely the quality of the signal would be collected in precise and advanced. So muscle anatomy we need to understand when we are talking about SEMG part. So muscle tissues will consist of fibers. That means whatever the muscles area would be available, it consists of the fiber, and that will be categorized into the three types. That means we can say type skeletal or cardiac type or smooth type. So that means in each case there is a certain structure and the functional characteristics will be there that we need to study for a specific role. And what are the mechanism behind for the muscle contractions? That means muscle contraction will occur because of the process called sliding filament theory. Whatever the sliding part filament theory would be involved here, where the whatever the actions and myosin filament will involve, that will be the slide past each other, and it will lead to the muscle shortening and it will generate the force. So force generation would be the mechanism will involve here. So muscle anatomy and function is very important while talking about generation of EMG signal. That means when we are going to collect the signal, that means the signal analysis is our part, and then we are going to utilize that signal for a knee abnormality analysis or for a human activity recognition. So here the generation point of view, the process will start where we have placed the sensors which are motor unit action potentials. This will be required for collecting of electrical signal that has generated by activation of motor units, and it will be reflected according to that firing of muscle fiber using that contraction and relaxation process. After that, signal transmission and detection. So signal are transmitted by using of the whatever the neuromuscular junction will be there, and it will be detected by the invasiveness, whatever the invasive non-invasive condition. So non-invasive, when we are talking about electrode, so that is the place on the skin. So surface electrode will be detected, and we are going to enable the study of muscle activity pattern. What kind of pattern will be generated, what are the signal analyzed based on the various pattern which will be available during various tasks, like if you are running, if you are walking, so how your walk will be there, how your if you're sitting, so what are your pattern would be there. So muscle activity will be measured during various tasks. That means signal will be transmitted detected by the electrode, and finally various factors will influence this signal. That means electrode, how you are placing, how the muscle fatigueness will be there, how the skin. So we have to understand the skin impedance, which will be significantly affect the amplitude and what are the quality of the signal. So if we'll recover the quality EMG signal, that will be collected during the measurement. So once you have measured the signal, you need to store the signal in a particular format, and after that we need to analyze whether their signal conditions are needed or not. So there is a history behind the EMG, because when we started, we already talked about 19th century, which was initially experiment was done on muscle activity, electrical activity. After that, last 25 year, like from the 20th centuries onward, that has witnessed the various significantly technical advancement happened in EMG as well as other physiological signal, because of the development of more sophisticated recording devices are available, and various advanced signal processing technique has been developed. So related to EMG point of view, the technique which we are going to utilize, particularly we are going to use various sensors, various bands which are readily available in the market. We can easily buy that all these sensors, that is the recording, and then we are going to analyze the electrical activity which will be generated by the skeletal muscle, and we have to access the muscle health, or what are the muscle functions are there. And nowadays every day the EMG analysis are becoming more and more modernized. So that means whatever the modern EMG integrators are aware, that means they are using advanced digital technology, and whatever the technology which we are using, that would be helpful for medical diagnostic, neuroprosthetics and rehabilitations, and sports science. So in sports science, there is a various injury or analysis part is very important. So here EMG analysis is very crucial here. So surface EMG under that category we are going to utilize two types of electrodes. That means surface electrodes and needle electrodes. What are the advantage of the SEMG electrodes over the needle electrode? It's a non-invasive. We can easily deploy. We can. There is a minimum risk will be there, and it's suitable for long-term use and control. And also we can easily handle as compared to IEMG needle. So SEMG versus IEMG, the electrical impulses will be generated by skeletal muscle contraction or relaxation. So EMG signal will detect the particular pattern of the muscle when it will contract and provide the valuable insights of neuromuscular function. So we can see here when we are talking about EMG, that is connected to lower limb part. So this is the representation of lower limb muscles. These are the muscles would be available. These are the anatomy part would be available. So surface EMG signals are particularly electrical signal which will be generated by muscles, and we can detect through the surface electrode. So we will place the electrode in a particular area of the skin, and here it is stochastic in nature. When we are collecting the signal would be available in frequency terms 10 hertz to 500 hertz. Amplitude variation would be 0 to 10 microvolts, and it's a non-invasive. So this is the EMG connected to lower limb. Now after surface EMG already we discussed, we are placing the electrode on the screen will measure the electrical activity of the muscle, and it's a completely non-invasive method. By that way we are going to access the muscle functions and what are the coordinations are needed. And intramuscular EMG, that means it's a whatever the technique we are using, inserting a needle, that is IEMG electrode we are using, directly insert to the muscles, and we can record the electrical signal. And it is a very precise assessment as compared to SEMG, because when we are inserting more, that means precise way advanced techniques are there, individual muscle fiber will be excessive. So mechanism of EMG which can be analyzed here, how we are going to apply EMG's electrodes. So we have to place the electrodes or we have to apply needle electrodes. Both way we are detecting and recording the electrical signal which will be generated by the muscles fiber during contraction. And we'll see the nerve test will be there, muscle test will be there, electrode has placed within the muscles, capture the signal and it will be amplified. That means signal conditioning part will be involved, and we have to display on the whatever the monitor we are going to use. So it will display, the waveform will be displayed on the monitor. Sometime we can say that it will be noisy signal, so we need to deploy between various signal conditioning. Attenuation would be there or amplification would be there. Various signal conditioning part need to be involved. So amplitude and frequency of the signal which will reflect the muscle activity. So various muscle activity, various pattern that can be analyzed, and it indicate the what are the neuromuscular functions or any abnormality will come, that also we can analyze through that signal only. That means by using of frequency and amplitude. So how the EMG signal generation part will be there. So we'll talk about generation in human body, which can be analyzed when we have place this sensors or this whatever the sensor we are using, SEMG or IEMG. So we have to understand there are various fiber, nerve fiber, muscle fiber, or motor neurons are available. By that way, we can see the once muscle contraction will take place. So it is when SEMG will be placed, it will just manage by the surface electrode, and surface electrode will be able to process like electrical impulse which will be go to the spinal cord, and then whatever the nerves will be there, how it will go for myofibril, and this is the action potential will be generated. So that means representation of the nerve and muscle system of EMG signal would be there, and this is the neuromuscular system structure which can be analyzed. So if you interpret the EMG data, that means if you are going to be applied to EMG analysis, we have to understand the particular EMG data which involve the understanding and what are the muscle activation patterns are there. So basically, we are going to perform the various fatigue analysis or co-contraction of muscles. So various advanced signal processing techniques are used for extraction of meaningful information, because we know that the signal would be raw signal. That raw signal would be converted into original signal, or whatever the, like, without noise, that denoising technique will be applied. So extract the meaningful information, which is very important, and how it is why it has the various advantage, because provide the high temporal resolutions, accurate diagnostic part will be there, and it is very good for localization of pathology. And again, we'll talk about when we are going for apply for dynamic testing, that level it will be helpful. And some pros are some advantage will be there. So disadvantage, it's sometimes economically inefficient and limited diagnostic specificity will be there. And person who are applying this kind of process, they must have skill. So skill developed dependent interpretation will be there, and it is invasive nature, that is definitely preciseness would be very limited. So if you are going to precise output, then you have to apply for more invasive. So EMG, when we are going to apply, it will play very crucial role in diagnosis, in management of various neuromuscular disorders. So people are facing that kind of problem, or muscular dystrophy, or amyotrophic lateral sclerosis, ALS, or peripheral neuropathy. So basically, when we are using this kind of technique, it access the muscle response when we are going to apply the rehabilitations, or any physical therapy intervention would be given to the patient. That means after injury, after the particular injury analysis, the rehabilitation would be aided. So that case, muscle response would be computed. Now we are going to concern about how to deploy the activity recognition or abnormality analysis, or any kind of abnormality that can be measured especially for decision making point of view. So it would be categorized in terms of four stages. So stage one, that means as we have seen so far, related to signal collections, data collections. So data would be collected from various sensors. Sensor would be available either from smartwatch, either from electrode, either from smart fingers, smart rings, smart belts, various smart gadgets are coming. Smart shoes are there, shocks are there, Bluetooth trackers are there. All are these wearable devices are very important, which is required to collect the physiological signal. After that signal has been stored inside the memory, and we are going to utilize them in terms of diagnostic purpose or segmentation purpose. So here, basically, when we are deployed to the artificial intelligence, so basic characters of artificial intelligence is we have to extract the feature. So feature extraction, feature selection, and the features are very important. Particular kind of domain, like if you are directly playing with the numbers, so time domain. If you are transforming them through the frequency domain with the help of Fourier transform. So by that way, we are going to concern frequency component, which is available in the signal amplitude component. So when we'll receive the various feature, this feature will feed to the classifier in terms of machine learning. So the data would be available either in terms of label or in terms of without label. So that means label data that can be solved by various supervised learning technique, like either by SVM, KNN, or distance tree classifier, or random forest classifier, or we are going to extend them from artificial neural network to the deep neural network. So deep neural network, we have extended multiple layers, and layers are responsible automated feature extraction plus representation learning. So that way we are going to apply, and then we are going to analyze the activity. So there is a activity interface would be available. So activity interface, that means how the human activity will be analyzed, how we are going to apply the abnormality analysis. So here the complete processing will take place, the how activity recognition will take place using the data equation system. So data equation system is nothing, we are going to utilize the signal with respect to band. So we have the certain bands are available. So this band would be collected the data from the muscles, and then during the contraction the signal would be collected and will be the as a raw EMG signal. and this signal would be given to the pre-processing part. Here pre-processing part, at that level we are going to concern about like signal conditioning analysis. So here we are going to apply filtering or various signal processing technique like windowing or normalizations. After these three steps, the signal would be available in suitable form, and then this signal would be given to feature extraction process. So in the feature extraction point of view, we are going to extract the feature time domain features, frequency domain feature, or combined features or hybrid features, time and frequency domain. And also we need to know the feature which we have extracted. Some features are not relevant or not required, so we have to apply feature reductions, dimension reductions, or by using of the required feature, that would be the consider as a feature selections or feature ranking. And all this feature will feed to the classifier, and classifier would be again categorized into label or without label data analysis, either by LDA, PCA, or convolution neural network, support vector machine, multi-layer perceptron, k nearest neighbor, or descent tree classifier, random forest classifier. And then we are going to apply the certain activity. So activity prediction will take place by using of this artificial intelligence techniques. So once we have analyzed the human activity recognition, that would be done by two ways. First is sensor based, another one is vision based. So vision, that means again we are going to utilize directly camera, or computer vision or machine vision will involve, or here in our concern we are talking about sensor based. So sensor based, we have various type of sensor that can be utilized like EMG sensors, IMU units, gyroscope, accelerometer. These are the sensors that are readily available, which can be utilized for human activity recognition. So as I said previous diagram, we have to apply the pre-processing. Under the pre-processing, the procedure would be denoising of the data, because once we have received the raw signal from the sensor, because of the known invasive nature of the system. So data aggregation system will give the data to the pre-processing. Pre-processing system will denoise, apply segmentation by using of various signal processing technique, windowing technique, overlapping technique, sliding technique, and then which appropriate signal, suitable signal will feed to the feature extraction. Feature extraction also would be applicable either by time domain technique, either by frequency domain technique, or either by combined technique. So as per the PCA analysis, we are going to reduce the feature, we are going to rank the feature. By that way, we are going to identify which features are suitable. So this is the human activity recognition classification, which can be done by sensor analysis or by computer vision. So computer vision analysis, basically we can say gate analysis we are doing. We are going to capture the image, and that image we have to see the posture or particular activity of the human. What is the particular deviation will come in his walk, is running, or whether he is sitting. So that is the way we are going to apply the activity. So similar way, various research carried out. We have done the various literature also. Based on the literature, we identify the algorithm has been categorized into four stages. First stage, machine learning. So many people have utilized for MN activity recognition for specific for support vector machine, k nearest neighbor, Bayesian classifier, k means clustering, or random forest classifier. So basically in support vector machine classifier, we are going to deploy the hyperplane. Based on the hyperplane, we are going to separate the data, that means separate the activity part. Same way we have implemented artificial neural network. Under that, various neuron has been created. Neuron is nothing, it's a processing unit. So based on that, processing units are responsible for extraction of feature, and the after feature will be extracted, we have to connect to the activation function for applying the thresholding or introduce the non-linearity, and then last stage we are going to apply the activation function for classification point of view. So classification, later on we are going to extend more number of hidden layer. So that means feature extraction will increase by number of layer will be added. Likewise, various architecture has been provided. Convolution neural network, the operation of multiplication will be replaced by convolution operation. It's a very popular operation in signal processing.
Then recurrent neural network, the recurrent architecture will be aided, transformer based architecture, generative AI. So we are going to generate the data with the knowledge of previous training. So new data will be created, variation autoencoder, and currently we are using the transfer learning. Transfer the weight of the previous design towards the new design. So weight which we have utilized for particularly one kind of data set, that would be utilized for new data set also. So under that bidirectional encoder representation from transformer, this methods has been developed, generative pretend transformer GPD, residual network or visual geometry group VGG, Google Net, UNet. So UNet has designed for particularly the segmentation point of view, mobile net. YOLO is specific for object detection. So various way we are going to analyze the object, and hybrid. So hybrid CNN can be combined with RNN. Autoencoder will be combined by generative AI, or transformer will combine with convolution neural network. Ensemble models, so various model which will be ensembled and find out the which is the weakest part or strongest part will be there, which is connected to time series data analysis would be done by the LSTM or some different model that will be connected to CN. So these are the methods are available. So we have seen that in literature review, we have seen identify the people have developed various signal processing operations, space for WD or EMD analysis for a specific feature extraction, and they have analyzed the lower limb activity recognition. So they have proposed hybridizations of WD and EMD method, and they have utilized classification of lower limb, and with respect to wavelet denoising and ensemble empirical mode decomposition they utilize. And classification they have done by LDA, which they reached 90.69 accuracy. Health subjects were there and 97.454 knee abnormal. So basically, in this research, that means manual feature extraction and selection carried out. It cannot learn complex relationship between features. Accuracy also can be improved. So related to another work which has been submitted, published in the different journals. So they have utilized lower limb recognitions of the movement using machine learning methods, and they have utilized bispectral map of wireless EMG measurement. So they developed the particular framework which classify the five activity using EMG or machine learning algorithm. So machine learning algorithm basically very important because signal was recorded by ACMG sensors during the activity from six lower limb muscle, and basically manually they have done feature extraction and selection. Data set also was limited, but they cannot learn spatial or temporal features by using of this technique. So we found various methods like SVM, CNN or LSTM, CNN plus gated unit, IDB, ImageNet or ResNet 18. All these methods we receive accuracy 97, 98, 99. So complex feature extraction carried out, sometimes complex, that means joint angle prediction is very important. While talking about improvement, and we can see that when we are evaluating offline data, there is a certain limits are there when we are talking about real-time clinical validation, and also it need to be adapted for broader or different tasks also with respect to different activity. And also when we are talking about resonating this method, accuracy level reached 95.3 only. Under that, gate analysis was carried out. So because of that reason only, information loss may take place because of the frequency recognition or limited gate they have taken. So likewise, one-dimensional CNN or VMD, artificial neural network, deep learning. So deep learning is limited processing power or integration challenges are there, or ANN algorithm must be applied for the both able body people or disabled body people. And VMD method is very popular method related to feature extraction. So method has limited applications for patient's condition. And with respect to one-dimensional CNN, It require more development, more testing with respect to the exoskeleton analysis. So related to our analysis, that means what we have implemented. So first we have implemented machine learning framework with respect to handcrafted feature extraction. This handcrafted feature extraction was implemented for lower limb activity predictions, as well as we have analyzed the knee abnormality. So what are the knee abnormality will be there? We have applied the one dimensional SEMG signal which we have taken. So according to this problem statement, we want to classify the human lower limb activity. That means what are the human lower limb part will be there with respect to machine learning, and we have utilized the handcrafted feature extraction. So related to when we are talking about classification, so here we are going to classify lower limb part, and we have implemented various machine learning method. And in machine learning method, the basic important part is feature extraction, feature selections, and then we are going to deploy the machine learning method. So one of the popular data set which we have utilized plus one. These data sets sourced from plus one as last updated in May 30, 2023. And in this data set, total 14 healthy individuals they participated, and three different training regiment was there. So according to this data set, walking condition or leg flexion like standing person would be there, or leg extension means sitting condition would be. So when we want to apply the recording point of view, so EMG was recorded by using of vastus medialis muscles, and they have utilized goniometer they place on knee joint MWX that is the data log device, and with respect to 8 digital and there was 4 analog channel were utilized during this recording. So EMG and goniometer data, particularly when we'll take the data, we have to store the data. So that means definitely we are going to apply the digitization process. So data was sampled at 1 kilohertz to avoid the problem related to the aliasing and all. So stored via Bluetooth, and the data which has been collected, that means related to the aging people, that means related to certain 7 to 28 years. Our height was considered certain 5.88 to 174. Weight was considered. Two experiment sessions. One is standing and sitting. Another sessions walking randomized. So person was walking, and we can say this is the raw sample data of the sample subject was collected by the channel 1, channel 2, channel 3, channel 4 and channel 5, and each motion repeated 5 times. That means they every one interval they repeated, and they were giving the 5-second rest also they provide. So in our analysis, when what we have implemented, so when we are talking about image processing or signal processing, that means that signal processing is very important, where the pre-processing part is one of the important requirement. So once we have collected the signal from the lower limb, we know that the signal has been acquired through the sensors. Signal acquisition part will be added. Then we know that compulsory the signal which we have collected definitely would not be appropriate for further processing. So that means we need to know that denoising or signal conditioning part would be added. So here at pre-processing level, we utilize normalizations, we utilize VMD, and then we have find out the signal which will be decomposed into various IMF. So here IMF1 to IMF5 which will be extracted. So this is the correlation coefficient which will be collected from each IMF, and will select which IMF which has the maximum correlation coefficient value. So if the IMF3 having maximum correlation coefficient, which will fit to the embedded wavelet, and then we are going to apply that particular segmentation algorithm, then feature extraction would be completed. After this feature will feed to the machine learning classifier. So machine learning based classifier was implemented here, and based on the three conditions, sitting, standing and walking will be analyzed. That would be the output analysis we can apply here. So variational mode decomposition that we have applied during the pre-processing time. So here what is the variational mode decomposition will do? As we know that signal which will be collected from SEMG part, first we process through the Z score standard normalization. So first we have to normalize them. Then we are going to apply denoising. So denoising would be applied through the VMD method. So that VMD applied for denoising, particularly after applying of the normalized data. So once normalizing of data completed, we need to apply VMD for denoising. So various adaptive signal processing, we know that would be done on VMD. So VMD what exactly will do? It will apply to convert the known stationary signal into discrete number of subsample, and this subsample is called modes. So according to that, efficiently we have break down the high and low frequency signal to the less, particularly no linearity, that consists of smoothness and time series complexity. So VMD we have taken from the particular source, and it fixes the issues with mode mixing. Sometimes mode mixing will be the problem, mode size will be the problem, endpoint confusion will be the problem when we are going to utilize other decomposition method like EMD or EEMD, or like different other techniques are there, more decomposition techniques are there. So VMD split the particular signal into intrinsic mode functions, IMF. So following mathematical technique will be applied. It will identify the FM signal. So IMF for the each signal would be there. N cos phi nt. N is amplitude, phi n is the phase, angle of the phase. So two conditions must be fulfilled by IMF of the VMD. So VMD then convert into IMF. Then each IMF having the center frequency that is minimized, and then total all IMF 1 to 5 equal to the original signal. If you sum them, it will be original signal. If you take their center frequency bandwidth, it will be minimized. So under that, we are going to initialize the signal that is decomposed. According to that, we are going to utilize equation 5, which will be available in the work. So again, we have to apply the equation number 6 to update for WK, UK and WK, and then we have to solve the problem of equation 7, and then we have to update the lambda k. So this is the 3D visualizations of IMF obtained from VMD. So VMD component with respect to in 3D dimensional in terms of frequency and time. So the related to the threshold would be there. Then yes, if it is no, going back, initialize same. Then if it is yes, output of IMF would be available as per the your equation 5, equation 6 would be there. So according to that, this flowchart will reflect the VMD analysis. After that, whatever the empirical wavelet transform we are using, that is required and that will be applied on selected IMF. So we have to select the IMF which correlation coefficient is greater than 0.3. Otherwise, ignore other IMF only. So suppose if you receive IMF 3 more than 0.3, remaining is less than 0.3, we have to ignore them. Select the IMF for VMD that is processed by the whatever the empirical wavelet transform which is applicable, and EWT is popular method which is applied under the adaptive signal process. So we have to understand that signal has been divided into numerous low power subsignal with a small support spectrum Fourier transform. So empirical wavelet transform will create a segmentation of the Fourier spectrum of original signal. That means it will segment the Fourier spectrum of original signal by using of the wavelet filter. That means there is a bank of wavelet filter would be available. So this is the empirical wavelet transform method will be there, analyzing the known stationary non-linear signal. So we have to construct the filter bank by dividing or decomposing the spectrum of input signal, more accurate and relevant decomposition of complex signal. So here signal will be decomposed by using of, so wavelet transform is very popular while applying of multi-resolution analysis, and multi-resolution analysis component will capture the local characteristic of the signal. So this is the initialization, then Fourier transform, then compute the maxima, find the omega 0 to omega n, then choose the y with equation 5 with respect to various omega will come 0 to 1, 1 wn to wn plus 1 or previous to current. So by that way it will decompose, and finally various multi-resolution analysis will take place. That component will come and we have to find out the output of which is the MRA, which consists of oscillatory component. That means that consists of the local characteristic of the signal. So after feature analysis, feature extraction will be applied. That is used to draw the relevant structure within the signal. So time domain feature set, mean absolute value, root mean square value, zero crossing, or kurtosis, skewness, standard deviation will be calculated. Same way we are going to calculate frequency domain feature set, mean frequency, median frequency, and band power. And entropy feature set will be computed by permutation, distribution, spectral entropy, or phase. These are the feature we are going to use and focus on relevant structure. Then we are going to apply ensemble, which can be applicable by the data set, and the data set which we have taken random subset D1 to D4, D5, 7, and then we are going to deploy the KNN classifier and we have to predict the output. So this approach combined the strength of K nearest neighbor. That is, what is the K nearest neighbor strength would be there. We have to deploy ensemble learning. We have to deploy random subspace technique. So we can improve the accuracy, we can improve the robustness and efficiency. So D1 to D5, D7 will be categorized into three different trees. And then we are going to deploy KNN classifier with respect to 1 to 3, and we are going to predict them by P1, P2 and Pn, and we will get the maximum voting. That voting will tell us KNN1 will be the final prediction, KNN2 would be the final predictions, KNN3 would be the final prediction. So by that way we'll improve the accuracy, robustness and efficiency. And this was what we have implemented in MATLAB 2022 version. For sample which we analyze, we have selected 5-fold cross validation, 5-fold, and 80 to 20 training and testing data we have considered. That means we have taken 80% training data, 20% testing data. So again, signal decomposition which can be applied by signal processing technique. So overlapping window which can be applied here, size was considered to 50 millisecond, 50% overlapping. So first we have preprocessed, then selected IMF, then applied the empirical wavelet transform, and then extracted the feature in terms of time domain, frequency domain, and combined, and then going to apply machine learning. So result will be collected from ensemble space K nearest neighbor method, which has reached to 98.9 accuracy, 98.8 F1 score, and 98.73 sensitivity. So this is the subject wise accuracy obtained from we applied VMD, VMD EWT, and various machine learning library. So VMD certain limit will be there, VMD EWT also certain limit would be there, and then combined way we have received the 97.2, 97.7, 99.6 like that. So this is the comparison graph for VMD EWT and VMD EWT. And also we need to find out the box plot with respect to performance parameter which can be obtained from EMD, EWT ensemblement. So this is the state of arts comparison. So our comparison of the performance obtained by the our methodology has compared existing way with respect to same data set. So wavelet transform, ICA or EEMD, So data set applied related to same, and then feature extraction was carried out by time domain, frequency domain, entropy features, or combinedly. So our proposed technique VMD and empirical wavelet transform, which we have extracted feature by using of time domain and frequency plus entropy, and classifier which we implemented ensemble classifier using the k nearest neighbor on original data set, and data which is collected from EMG signal. Three motions we have considered only, and we have reached 98.9%. So through this problem statement, we propose that VMD EWT based feature extraction and classification was carried out by particularly this ensemble space k nearest neighbor, and specific for lower limb recognition we implement. So various steps are applied here: normalizations, VMD for IMF decompositions, EWD for multi-resolution analysis, feature extraction, which is very common, which is very important for time domain, frequency domain, and combine. An ensemble subspace was applied for k nearest neighbor, and this feature selection method was not considered in this analysis because the next objective you have to identify which is best feature selection method will be there specific for knee abnormality detection. So in another case, we have identified and we have detected the knee abnormality using various feature selection approach. That means under the feature selection approach, when the person is walking. So in this analysis, we have utilized statistical and algorithmic feature selection method, and also this feature extraction selection method helpful for discriminative time and frequency domain characteristics. That means we are going to provide the discriminative way for time and frequency domain features, and we can lower the dimension also and improve the model accuracy. That is the major problem statement which you have considered here. So under this analysis, we have taken the publicly available data set UCI database. Here in this data set, 22 male subjects are there. 11 subjects consist of knee abnormality problem, and it was already diagnosed by the professional people, and 11 was considered normally. That means there is a no abnormality would be there. So data was collected by them by electromyography and goniometry equipment. So goniometry equipment, MWXZ, data log biometrics will be there. So the patient undergone three movement. By three movement, we can analyze the behavior that is associated with the knee muscle sitting during the sitting time, during the standing time, during the walking time. So we have taken the data from same channel, channel 1, whatever the rectus femoris RF, or channel 2, channel 3, channel 4, channel 5. So ACNG signal acquired during the gait form. First condition, healthy subjects as well as abnormal knee subject. All these two categories of subject has been considered here. Now, according to the methodology point of view, we have to first consider the data equation part. So during the equation part, we should know that if the knee is normal, what kind of signal will be collected. If it is knee is abnormal during the walking or during the working point of view, what are the signal will be covered. Then the signal would be given to the pre-processing part. Pre-processing point of view, where the signal processing would be very important here. So we have to normalize, we have to apply empirical wavelet transform, and we have to deploy the segmentation. So segmentation has been carried out. So finally feature extraction will take place, or various feature extraction method will responsible to analyze the selection of features only. So ANOVA method was applied here, and we have received the features and we have received the selected features also. And this feature will feed to the classifier, SVM, ensemble, k nearest neighbor, and whatever the Bayesian classifier was there. So through that new Bayesian classifier, we are going to identify the person is normal or the person is suffering from knee abnormality. So that would be given by the classifier. So feature extraction, selection, and classification. So here empirical wavelet transform, earlier also we have seen that, particularly for analyzing the non-stationary as well as non-linear signal. So EWT, as we have seen, initialize, apply Fourier transform, we have computed maxima, we have find out the frequency component 0 to n. So it is applied for adaptive signal decompositions, and it will create the segmentation of Fourier spectrum of the original signal. So we can say Fourier spectrum original signal by using of various Fourier frequency component W0 to Wn. So that original signal are passing through bank of various filters, wavelet filters 0 to W1, phi 1, phi n, phi n minus 1. By using of this EWT, we are going to analyze the particular, that means multi-resolution analysis. That means we compose the signal into MRA, and that MRA component will be combined. That means this component capture the local characteristics of the signal. Then we are going to deploy the segmentation part. So the segmentation part will be the same in terms of signal processing level. So overlapping windowing techniques are there, where we can use various windowing technique that would be covered 50% overlapping using 25 to 250 millisecond used for timing. So feature extraction will focus on relevant structure in the signal will be there. Entropy will quantify the degree of randomness, degree of disorderness, and by using of the probability distribution function. So entropy features after getting of this IMF value. So after this, we are going to understand the selected feature which has been applied by the ANOVA. So ANOVA is analysis of variance. So it's statistical technique which will be utilized for difference among the group mean in a sim. So ANOVA help to identify which features are most relevant, which are not relevant. So feature will be given by rank down. So their F statistic will be given. So F statistic will be calculated by using of the ratio of the between group variance within the group variance. So higher if F will be there, F static will be there, indicate that higher of the rank of feature will be there. They are more significant. If the lower rank would be there, less significant. So we are going to identify the relevant features which are most relevant and significant as per the predicting the target variable. Then we are going to consider the data will be divided to two category, training and testing. So in ensemble method, which we have taken the subset, data has been divided to three subset. So ensemble learning will combine the all output of multiple decision tree. So decision tree will start from subset 1, the decision tree classifier, then apply the decision tree, so which is trained on different data set, subset only. So data set of the 1 trained by the decision tree classifier 1, data set of 2 trained by decision tree classifier 2. So likewise decision tree classifier 3 also would be applied like that one. So this is called as a ensemble method. Also sometimes we can say as a bagging method. So which stands for bootstrapping aggregate. So our primary analysis, primary data analysis is that related to this bagging method is we have to reduce the overfitting problem. That means overfitting problem when we are training the model, the result accuracy is good. When we are testing the model, result accuracy is not good. So to balance the data, we have to apply the bagging method to reduce the overfitting. So this work also we implemented MATLAB 22A version. Data was divided into category, 80% training, 20% testing. Total 40 features we have taken from the 5 channels, which is extracted based on entropy feature. That means based on the entropy feature which we have extracted here. So 25 significant features are there. Here there are total prominent features from each channel we have extracted, and we have to select by them whatever the analysis of variance we are doing. So ANOVA method was utilized. These are the sample of channel was there by using of multi-resolution analysis, MRA1 to MRA5 for empirical wavelet, and this is the empirical wavelet transform which will be applied, MRA1, MRA2, or this is the other method. So that means obtain after applying EWT or of normal subject. So this method testing result which we have received by the all features and after feature selection. So testing accuracy 19.7 as compared to KN and SVM and Bayesian classifier 99.8, 99.7, 19.7. And after feature selection, these are the analysis. And this is the training time which we have computed by using of 17.483 second, 6.5 second, 1200 of second, 5.60 second after selection. And feature was obtained by the 6300 hours. Absolute value will be second only. So one will compare the performance analysis with respect to existing method. So here they have utilized three motions 81, 92, 92, 96 for F1 score and accuracy 97, 97, and here three motions are there. Abnormality will be computed 96%, normality 90, and both group 94. But our case accuracy 99.6 for knee abnormality analysis, precision 99.5, recall 99.8, and F1 score 99.7. And the training time which has taken to develop this model 5.6 seconds. So if we summarize of this work, we have implemented the EWT weight feature extraction method with ANOVA feature selection method. So previous case there was no feature selection method was there, and various machine learning framework applied, and finally we applied ensemble method for knee abnormality analysis. The dimension reduction method which was very important, which can be applied using a ANOVA method. Total 40 features from 5 channel we extracted based on entropy features. So here 25 significant and prominent features from each channel we have collected by using of ANOVA algorithm. And after applying of this feature selection, ensemble classifier has shown the impressive accuracy 99.7 in terms of accuracy, and training time also they have reduced. So after machine learning, that means we have tried, that means feature extraction and feature selection, we have implemented deep learning part, deep learning model for automated feature extraction. That means automated detections of human lower limb activity. Whatever the human lower limb activity would be there. Here we are going to collect the one-dimensional SEMG will be converted into two-dimensional SEMG signal would be there. So how one dimensional would be transformed into two dimensional? So here the problem statement that has reflected here parameter extraction with wavelet transform based synchronization method would be there. That is available with respect to neural network for automatic detections for lower limb activity based on the EMG signal. So if you have 1D, we have to transform into 2D. 1D transform into 2D by using of spectrogram. So spectrogram will be utilized for accurate detections and classification, and also we can increase the activity recognition. So we have to improve it activity recognition. After that, the contribution of EMG segmentations and feature extraction. So segmentation based feature extraction we are doing, that will be done by the discrete Hermite wavelet transform, and that would be done by the synchronization method. So here we have significantly improved the SEMG signal analysis by precisely separating the signal and extracting the accurate parameter. And finally, activity recognition is feature feed to the CNN. So deep convolution neural network, two-layer neural network has utilized. We have combined knee joint angle prediction also for accurate multi-class classification. That means the classes has increased instead of two for the lower limb actions. And significantly, we have increased the EMG based activity recognition. So data set, here we have utilized UCI EMG lower limb data set and lower limb the physical action data set. So here data set was covered by 22 members, which is available 11 normal, 11 abnormal. For action point of view 4, related to 3 is normal, 1 is 3 is male, 1 is female. And sampling frequency was considered by collections 1000 hertz, and channel was considered year 5, year 8. Activity was considered 3, sitting, standing and walking. Here 20, 10 normal, 10 aggressive. So data set link for the link. This is a UCI machine learning repository for data set in lower limb, UCI machine learning repository, physical action data set. So here when we applied the methodology, we have to taken two data set, we have deployed discrete Hermite wavelet transform based synchronization. Synchronizing what part we are doing, signal will be there, then segmentation. So we are going to segment the signal into three different time. So three different time analysis would be there, and then we are going to apply the parameter extraction. So what extracted parameter will feed to the layer, generalized regression and neural network. So number of layer would be there. So here this will apply the knee joint angle prediction. So joint angle has predicted, then the signal would be taken from this parameter extraction in terms of 1D, convert into 2D, combine and apply various layer 1, layer 2 and fully connected layer, connect to softmax layer. Softmax layer is nothing to classify the output of the previous layers. When we are going to classify them, the person is under the sitting situation, standing situation or walking situation. So this is a deep two-layer multi-class, multi-scale convolution neural network. So discrete Hermite wavelet transform based synchronizing, how it will work. So related to when we are talking about this Hermite wavelet transform, this is the synchronizing method is there. So when we apply the wavelet transform or Fourier transform, related to that, the decomposition part, it's a complex part will be there. And we should know that when we are talking about non-stationary signal, into the meaningful oscillatory components are there. So we have to achieve the high resolution time frequency representation. By that way, the signal will be high resolutions and time frequency for feature extraction, for denoising and analysis. So as we know that EMG signal are nothing, it's a non-stationary signal. It's a containing transient muscle activities with respect to variable frequency component. As we know that traditional analysis was not sufficient in terms of resolutions or localizations. Once we combine this DHWT and synchronous squeezing technique, this technique offer the powerful solution of detailed time analysis and frequency analysis. So we combine HWT and we are using orthogonal Hermite polynomial based wavelet. So wavelet consists of various kernel. So here polynomial based wavelets will be there, and this wavelet is helpful for multi-resolution analysis and synchronous squeezing transform, which is applicable to improve the time frequency resolution. So by that way, time frequency resolution will improve and we can concentrate the signal energy around the instantaneous frequency. So that means we have concentrated on signal energy with respect to instantaneous frequency. So it is the Hermite functions, it's a mother wavelet. So in wavelet transform, we have seen various wavelets are there. A discrete Mayer is there or Debye will be there. So here also this wavelet is mother wavelet. Hermite function we are using. Hermite function will be localized by the time or frequency domain both, because it has suitable for analyze the transient analysis or localized analysis. So DHWT will decompose the signal in two components. That means by using of Hermite wavelet basis function. So we have extracted feature which include pulse width, bandwidth and energy distribution. And after applying of synchronous squeezing transform, it is an advanced time frequency analysis tool which will sharpen the time frequency representation. And also we have computed energy. So we have reassigned the energy into spectrogram based frequency estimation, resulting high resolution would be obtained, and particularly this will be helpful for signal that is comprising the multiple amplitude and frequency modulated component would be there. So the signal which you have taken, this is the conversion of signal into spectrogram. So this is the multi-scale patches which will be extracted, pass through that this number of layer which are responsible extraction of feature. These are the convolution layer, and these are the convolution layer. This is the particularly ReLU layer activation and soft mix layer. So fully connected layer which will be required for classification. Here finally we are going to deploy the softmax layer which is going to classify three states: walking, sitting and standing. So this architecture of deep neural network which is applicable for multi-scale convolution neural network. So conversion of EMG to the spectrogram, we have received various patches, multi-scale patches are there, passed through the deep neural network which are responsible for extraction of feature. Then fully connected neural network which will be applicable just classify at that level. Softmax layer will generate the probability with respect to this number will be converted to probability. Based on the probability we are able to classify. So deep neural network which we have implemented here, that is two layer convolution neural network. Traditionally, we have seen that convolution neural network is analyze images or spectrogram with respect to a specific region. That is the respective region zones will be there. If you see the zone at the one scale, that means it will limit the ability to capture the feature. It's not vary in the size and shape. So particularly if you are looking for two-dimension spectrogram, that is the major important attributes here. So pulse width, bandwidth and energy distribution will be the feature here. So we are going to differ greatly in their size and appearance by using of single, fixed and scale restriction of the network would be there. So that is the all relevant details will be extracted here. So to overcome the certain problem, there is a deep neural network with multi-scale analysis applied here. So it consists of two parts. Part 1 generate the multiple segments of spectrogram with different resolution level. So scaling part would be added here. Second part, it perform the activity classification on your multi-resolution segments will be there. So this model will allow the this method allow the model to detect the better objects also, and whatever the feature will be have appeared various size will lead to the comprehensive understanding of the spatial context of the spectrogram would be there. So as per the architecture which we have implemented at the Python version 3.9 1.2, Keras utilized 2.10, and we have experimental setup consists of server equipped with 32 GB of RAM, Intel Xeon CPU running on 2.10 gigahertz, NVIDIA RTX GPU featuring of 8 GB graphic. So related to this implementation, we have proposed on data set 1 receive the walking that activity recognition accuracy 99.95, 99.85, 99, and average would be 99.90. So we have compared with the CNN plus gated recurrent unit or MyoNet, LSTM CNN or genetic algorithm PSO and SVM. So this is the confusion matrix which we have received on both data set DB1, DB2 is the training accuracy with respect to DB1 and DB2. So this is the training and validation accuracy. This is the loss which we achieved 100 epochs. This is the particular training loss. This is the validation loss. This is the training loss and this is your validation loss. So this is the loss analysis which applied here, and we have compared with the existing healthy subjects with respect to this is the calculations, and this is the abnormal subjects, this is the calculation which you obtained with that. So in earlier method one dimensional EMG was there, here two dimensional spectrogram utilized, which is the examine of short lower limb activity. So proposed method works well with accuracy 99.95, precision 99.93, recall 91, so approach will be a step forward detecting the lower limb activity while improving the pull out the feature and group them. So we have taken the feature and grouped them, so it's a more accurate and reliable. So in future, researcher could try the system other limb activities also, and they work better for different type of patients, and rehab situation would be there. Now, in the third case, we have combined that 1D and 2D EMG signal. That means for a more improvement, the model was implemented by the deep learning. So here in lower limb activity EMG signal, we have utilized meta heuristic deep learning framework. And at that level, we have combined 1D and 2D. 1D signal alone, if you are using, spatial part will not be available. 2D, if you are using, temporal only will be available. That means temporal, we are missing that. So if you are going to mix them, we are going to deploy one-dimensional time series and two-dimensional spectrogram images. So because of this reason, this network will be helpful for spatio-temporal feature fusion. And as we applied the wavelet for denoising, we can improve the signal quality. We have understand the imbalance conditions. We have optimized by optimization algorithm, and we have ensured that transparency by using of explainable AI. So we have deployed the explainable AI model implementation. So here data set, UCI, MG, limb data set, and human gait data set. Gate dataset. This two dataset is available with respect to subject, sampling frequency, activity 3, and here 12 activities are available. When we are applying the model, the proposed model was implemented with respect to the data set. That means the data set was deploy discrete fractional orthogonal wavelet denoising technique, and this technique will be applicable by using of the this boundary midpoint minority oversampling technique. So BMS, CS, MOTE, and here various optimization algorithm applied like modified Puma optimization algorithm, which is required for loss minimization. So activity recognition will be received after receiving the minimum loss, and then we are going to deploy the various classes by using of convoluted cross fused spatiotemporal transformer model. So this is passed through the external AI. We have explained that, and based on that, we are going to classify them. So in methodology, first is DA4W. So discrete fractional orthogonal wavelet denoising technique we utilize. So particularly when we are going to identify the whatever the genuine SEMG signal will be there from the lower limb. So because the muscle signal is a very complex with respect to noise also would be mixed here there. And also artifacts also mixed like electrode noise or like a movement noise will be there. So DA4W method utilized for pre-processing process. It involved the fractional convolution and conducted across various scaling. So it's an advanced wavelet based denoising method which is connected to fractional orthogonal wavelet for more flexible and effective noise removal. So noise removal will take place. So this is the result of this method by showing the signal enhanced by the raw SEMG to RF and this denoise EMG signal. So first is raw, second one is denoise. So fractional order parameter will improve the this signal analysis and enable more effective and adaptive denoising as compared to traditional wavelet. So we have to apply another part, class imbalance handling method. That is the boundary midpoint centroid method, which will be applicable at after denoising. So it will be required for class imbalance problem was addressed by the previous method. So this method is a special method. It will generate new static synthetic data points for a minority class. So when we focus on that, the center point will improve the model ability to recognize the magnetic class. So this method target and critical boundary areas are there. So based on that, making the synthetic data more meaningful. And next, the convoluted cross-fuse a spatio-temporal transformer model. And that model, that means whatever the lower limb analysis we are doing, for that we are extracting local and global feature extraction, which are very important. So CNN are effective at the local feature, but CNN are struggle with understanding of global. So transformer with self-attention mechanism, we are extracting global feature, and this whatever the CCFS model will be there combined with CNN and transformer with strength the accurate lower limb analysis. So in our process, data processing we have done by using of two data which we have processed. One is one dimensional, two dimensional, to classify the activity. So model have three parts: one dimensional, two dimensional, CNN, then transformer, then spatio-temporal transformer with cross fusion layer. So we have extracted local feature by using of 1D, 2D CNN part. Transformer capture the deeper relationship, and the swim transformer, it's identify the long range dependency, because spatio-temporal transformer improve the pattern over the time. So cross fusion which we have done here, because we integrated both transformer output for better recognition, better utilization and classification performance. So this is the procedure: convolution layer, ReLU layer, convolution layer, ReLU layer. Like that, we have applied this convolution 1D block, then reshape, then images transform into the spectrogram images, then 2D, combine them, global pooling for dimension reduction, find, and then linear layer, then swim transformer, then fuse them. So this spatio-temporal block and swing transfer block, and then fully connected block, all this will be combined single node. Sigmoid is the classifier that will be classified two states only. Two states are there, that's why we are using sigmoid. If three states, four states will be there, we are going to utilize softmax. As we have seen, whatever the swim transformer part will be there, it's a long range independency, and spatio-temporal transformer, that part will be apply the movement pattern over the time. That means we are going to use feature extraction, swim transformer, spatio-temporal transformer with cross fusion we are applying. So cross fusion will integrate both transformer for better recognition or improving the data utilization. So after that, we are going to know that parameter optimizations, parameter updating, because we are going to improve the loss. We have to reduce the loss. So after every on experiment phase, we are going to improve that. So Puma method is a natural inspired metaristic method which introduced for solving optimization problem. So we draw the inspiration from hunting behavior of humans, how the hunting behavior. So we are going to particularly steal, tracking and attacking strategy when hunting prey. So proper parameter tuning is important here. Manual parameter tuning is a time consuming, or expertise also required, prone to error also. So optimization algorithm automatically process, saving the time and ensure that systematic exploration of parameter space will be. So we have to balance two objects. That means searching new region in the search space or refining the existing solution. Now explainable AI, which has utilized for prediction purpose. So model become more complex, rely on vast amount data, and inner working becomes less understandable. So inner working are unable to understand. So we have to enable interpret the decision. So external AI will make the black box, and based on the feature, so AI model more transparent and interpretive. So external AI highlight the which key features are important, which patterns are important, that can be used to make a predictions, and it will help to identify area where model is weak, model is poor, and will do the mistakes. So it will be solved by the external AI. So we have to solve them and it gained the tractions for simplicity and interpretability. So local explanations method like LIME or SHAP is utilized. So this line-based interpretability analysis for walking has been utilized. So prediction probability for sitting 0.03, standing 0.15, gait 0.8. So gait, non-gait, we have to explain that. So AI will highlight the features, patterns will make the prediction. External AI will highlight that where the model will weak, where model will do the mistake. So we have to gain the whatever the simplicity and interpretability will be there. So local explanation method like local interpretable model agnostic explanation method is utilized here for predictive. So the work has implemented on Python same the platform we have utilized with GPU support. So training data set consists of 70% of EMG signal and 30% from the testing. So this is the HUGADB data set and EMG data set for lower level. So here consider walking, running, sitting, standing, sitting down, standing up, elevator down, going up with the stair, going down, sitting, standing, walking. These are the value we have achieved. So these are the measure of proposed model of the these two data set of lower limb. This is the confusion matrix, and these are loss and accuracy graphics we have used: training accuracy, testing accuracy, training loss, and testing loss. Till that 50 epochs we have utilized. So these two data set, this is the confusion matrix has achieved. Now we have compared with the proposed model against existing approaches. So we receive 99.2 for this data set, and for this case 99.26, 99.25, 99.57, and 98.9. So the method was utilized cross-fuse spatio-temporal transformer network. It's a very novel architecture which we have implemented to improve the lower limb action by effectively combine of two data: one-dimensional temporal data, two-dimensional spatial data. So this is the network. We integrated several key components, including this fractional orthogonal wavelet and also various border midpoint centroid minority also we applied here to address the class imbalance problem. And we have applied optimization point of view Puma and for loss minimizations and leveraging the all this data and spectrogram in terms of images. So CCFST model achieve more accuracy, robustness or lower limb activity identification. So here in the last part, which we are going to see the how real-time way near probability analysis, which can be implemented for the particularly for human activity using SEMG signals. So in this case, we'll see that suppose if you are having lower limb part, this is the area where the lower limb will be applied and how electromyography signal will be achieved. So in this case, predicting the real time using the various deep learning model like CNN, RNN or LSTM. Existing data acquisition systems are very complex, more cost, and aim to provide a simplified, small and cost-effective prototype. So according to that, data will be collected 5 subjects performing 3 different activity. So this is the data acquisition part. This the IM candy. This is the data collected through the sensor as placed, and this is the Arduino. This is the through that we have acquired the data, and then whatever data we have recorded that will be obtained in raw form. So data pre-process segmentation, which will be applied by various methods, and will send the data to the deep learning model. Deep learning model will be able to analyze whether the subject is normal or whether the certain knee abnormality would be available. So when we are talking about EMG data equations, that means various electrode will be utilized. That is the alcohol pads were applied to skin for cleaning, and customized EMG data collection system was employed. So EMG muscle sensors with V3.0 cable electrode will measure the electrical activity of the muscles, that is filtered and rectified. The various sensors are available, that is biome candy small muscle sensor for EMG sensors, gel electrodes are needed, cables are needed. So all these are the particular feature specification of these sensors are available. Data recording will be taken care through this Arduino Uno, that is a controller, and we are having certain memory and analog output, and data flow would be there, and then we are going to record that signal. So once recording, which we applied here, data has been collected, then we have to apply the activity, then skin preparation and signal quality will be there, ethical compliance will be there. So information consent obtained from the particular students, and then we are going to apply the collections of these sample subject recording data, and then data filtering with respect to all the activities. That means noise reduction will take place by band pass filter, notch filter. Segmentation method we applied for overlapping window technique. Now we can say the signal has been filtered here. After that, the deep learning model, which will apply deep neural network, analyze the grid-like data pictures, convolution layer filter, that is input data to capture the spatial hierarchies, and pooling layers reduce the dimensionality, and fully linked layer, all this combined for classification. So recurrent neural network, also we are going to see that keeping the hidden states, store the information about the prior items, and it is good for context and order sensitive application like language modeling or sequence predictions. LSTM and RNN part model sequence are used for temporal data. It's involved for the particularly series forecasting data, speech recognition data, NLP. So LSTM networks gates are there, input, forget, and output, that govern flow of the data to capture the temporal dependency. So these are the performance metrics of DL model with respect to CNN, RN, LSTM. This is the training, evaluation accuracy, patient scores, and this is the real-time data which will be collected like that. So once data has been stored here, that is the procedure we can see here. So once we are connecting to the sensors to the particular patient, and then we are going to collect the data. So once data will be collected during the certain activity, and then we are going to store inside the system. So now that means the proposed data acquisition with simplified, small, cost-fixed system for lower limb activity predictions, your DL model, robust LSTM model, real-time data collections, and robustness because of the pre-processing pipeline offer a efficient way for predict the lower limb motion. So here hardware, there are many hardwares are available related to the work, like this knee bandage are available, or this is the process like how IMU equation system will work, like these are the sensors, these are microcontroller, regulator, and these are the battery and switch. So this is the implemented aging causes a functional decline. So nano steam projects intend to build this electro simulation system to reduce the patient visits. So knee angle help to determine the patient mobility during treatment, and low cost technology like ESP microcontroller, ESP6050 sensor incorporated into the wearable. So hardware that causes a reduction in precision of signal when we are talking about multitasking. These are the hardware related to existing work, like this kind of system is designed wearable robotic system for lower limb in the research to provide the stroke patients with the assistive assistive torque during the rehabilitation. This is the particular one of the most active research area in the field, SCI to hand gesture recognitions. This is the another hardware wheelchair navigations with respect to omnidirectional motions. So the Ananda Shankar it all developed this kind of hand gesture with omnidirectional wheelchair. For that, wheelchair controlling employing by wearable IMU and myoelectric sensors will be there. So various applications that would be there using EMG, like human computer interface, activity recognition, limb analysis, human emotion detections, prosthesis control, or disease analysis, gait disorder, rehabilitation assistant. So according to that research applications point of view, research EMG is utilized to investigate muscle activations patterns, biomechanics, and motor control. So it is instrumental in studying the movement and disorder, sports performance, ergonomics. Researchers are able to utilize EMG to gain the insights into particular mechanism underlying various muscle related phenomena would be there. So already we have seen that if there's C, this is the particular several hand gesture detection modality have been investigated over the past 3 decades. So recent year I have been seen that euro surgeon, whatever the in the field, that thanks to hardware advancement in the anti-blurring. So in this case, we have observed that this is a data glow architecture, low cost data glow effectiveness for categorizing hand gesture in context of deep learning. And additionally, they suggested the brand new spatial projection image based method for recognizing the dynamic. The previous case we have seen that this is the detecting device that especially for deliver helpful for tall. So propose for which ACMG is used. Research was done for the gather the particularly hamstring or whatever the quad strip AMG reading will be there for healthy volunteers muscles. So particularly the result estimation force, the location of the hip and knee joints and application in the real time. The same way this system, if you see that implemented on aging causes functional decline. So that NanoStream project intend to build a home electro simulation system. That knee angle help to determine the patient's mobility during the treatment. The low cost technology like microcontroller, it's incorporated to variable, and this hardware causes reduce the precision of signal, and then completely that complementary filter had best performance when we are averaging 0.6 degree improvement with MS. So related to that, this is the wheelchair navigations. They classifying 7 typical gestures that is done by the classifier with shape-based feature extraction, animated gestures. So one IMU sensors with respect to wrist and 3 axis accelerations or EMG waves and extension flexor signals are there that processed by the this signal. So real world classification with 5 healthy participation tested and algorithm for real time wheelchair navigation. So classification was done by this classifier for 94% accuracy, 5 user cross validation rate. Classification accuracy with respect to wheelchair user 90.5. So these are the challenges. Despite of numerous benefit, EMG has certain limitation, including interference problem, patient's discomfort, or need for skill in interpretation. Additionally, when we are talking about data interpretation, it can be affected by factor like a fatigue, skill impedance, or electrode placement also. So if we'll conclude the part, like a robust machine learning framework can improve the lower limb activity recognition for accurate own activity, lower limb activity recognitions. EMG as EMG shows that promise for early knee abnormality detections as we have implemented 2 signals, 1D and 2D. So that demonstrate the reliability for detections of this human lower limb activity, develop a cost-effective real-time equipment system, and include variable devices for continuously activity monitoring, multimodal data integrations for better recognition. We can use transfer learning, domain adaptations, exponential AI. We have seen that to improve the human activity recognition for particularly interpretable interface. In future, we can develop the real-time feedback system for rehabilitations and performance monitoring. Also, we can expand activity recognition, and also for clinical settings is our main key goal. So our aim is to enable the personalized rehabilitation protocols. Furthermore, we will refine particularly that research aspect. So these are the references. So thank you for the patient listening. Any query from the participant side?
Participants, we are open for the question if you have any. Sir, can we use the sensor for voice detection in Parkinson disease? Sir, there was one question from Monica. Sir, can we use the sensor for voice detection in Parkinson disease?
So Parkinson is the part which is the majorly coming because the that is particular muscles in the brain or certain motor activity. So voice recognition also can be helpful, but mainly the body actions will be deteriorate during the Parkinson point of view. So it can be one part, but once Parkinson will be degraded very time being. That means initially the particular gait, the body, the whatever the movement part will be there. So we are mostly identifying that, and the speech will be the second stage or third stage that can be done. That will be possible for voice point of view also, that can be possible because uh, that will be impact during the Parkinson.
Okay, sir. Another question from Pooja. So during data collection, there is some repetitive data and unuseful data obtained. How to remove it effectively?
So repeated means that means when you are collecting data, that means you have certain limit time. You just like you have kept the sensors on a particular skin. This is the invasive non-invasive part. So you are placing lower limb part. So during the collection, you ensure that you have placed properly, and whatever the that means collection device board like Arduino we have used. So during that time, how much time duration you have like collected data. So that duration would be there. Based on that, you need to set the other parameters like that sampling rate or everything you need to set, and as per that you have to apply that. So suppose if you have collected repeated data, that you have to ensure that what are the duration you have considered. Suppose 2 second or like a 20 second or 40 second you have considered, so definitely there is a repetition may be possible. So you have to ensure that time, and you have to just apply that.
Okay. Thank you, sir.
Uh,
So,
which
uh,
sensor data is more reliable, industrial grade sensor or lab or both? I could not understand. You are what way you are talking? Sensors, grade sensors, lab or both? Can you elaborate? What is your question?
Pooja, kindly elaborate your question. So, meanwhile,
Yeah. How
we
we
have
validate the EMG signal? As I said, that definitely denoising part would be very important. When we are collecting data, that means denoising will be very important, because in that invasive non-invasive part, noise will be the one of the important factor we need to attenuate through the signal conditioning. So that is the major requirement when you are deploying through the Arduino boards. So grid search or Puma search you are talking.
difference between grid search, CV, and Optima search, which is
Optima
best.
or Puma? Yes, you can purchase. That means this ebay.com, which is available. There are many sensors are available that is directly procured from China actually. So if you are able to purchase, it can be purchasable. So, but time taking, because it's coming from China, it is taking time. But sensors will be available. So reliability we cannot say, because sensors are what types of sensors you are buying. It is a dependent on the cost. Okay, so reliability would be the one factor. But as we have used all these sensors we purchase, some sensor we have purchased through the Amazon and all. Some sensors we purchased through eBay. That is from coming from China, but we have used. I have one project that is a healthcare monitoring system through the this TTDF. I am using that various sensors for elderly patients healthcare monitoring system. So we have identified the sensors we have collected, and all kits are coming. That gel and all the electrodes are coming. We have the correct way we are able to manage.
Okay. Yes, any further question? Okay. Any further question? Okay. If not, then thank you, Farooq sir, for joining with us and spending the
Yes, sir.
time with us.
Thank you,
I
sir.
hope
Thank
the
you.
students have get benefited about the whatever the research that you have discussed about the SEMG based lower limb problem. Okay. So uh, thank you participants for joining and thank you sir for joining with us. Okay. So participant, with this we are ending up our day 4. Okay. So we will be joining tomorrow again at 5 o'clock. So see you tomorrow, all of you. Thank you.
So I have shared my mail ID. Anyone having any query, they can contact through me.
Yes.
Thank you, sir. Thank you for the invitation. Thank you, sir.
Alright.
Yes.
Thank you. Thank you for accepting our invitation, sir.
Thank you,
Thank
sir.
you.
Thank you for
Okay.
participants also for patient listening. Thank you to us.
Okay.
Thank you. Bye bye,
So sir
everyone.
has said your his email ID also. Okay. So anyhow means I have said schedule over there.